Hello everyone, let's try to be a cheat code ninja today. This is a very good problem to understand how the two graph traversal methods DFS and BFS work and also understand the similarities and dissimilarities between them. We'll solve this problem using both these approaches. We are given n rooms which are labeled from 0 to n-1 and all the rooms except for room 0 are locked and each room contains a bunch of keys with the room numbers written on it and we have to use those keys to unlock all the rooms. We have to check if we can unlock all the rooms. Let's look at the example given. We are given 4 rooms and room 0 contains the key to room 1, room 1 contains the key to room 2 and room 2 contains the key to room 3. Initially we'll start at room 0. We'll use the key to unlock room 1 and inside we'll find the key to room 2. We'll unlock it and inside room 2 we'll find the key to unlock room 3. So we can see that we have unlocked all the rooms. Let's try to come up with an intuitive solution for this. Let's understand this problem with the help of this example. We know that when we unlock a room, we'll get a bunch of keys and using those keys, all the corresponding rooms will be unlocked. Initially, we are given that the room 0 is unlocked. We have 2 keys inside this room, key 3 and key 6. Using those keys, we'll unlock both these rooms simultaneously. We did not find any key inside room 6. Inside room 3, we found 2 keys. Using those keys, we'll unlock room 5 and room 8 simultaneously. Inside room 8, we did not find any key. Inside room 5, we found the keys to room 3 and room 9. We see that room 3 is already unlocked, so there is no point going to it again. So we'll just unlock room 9. Inside room 9, we have 2 keys. Those rooms haven't been unlocked, so we'll unlock them. Room 1 doesn't have any key, but room 2 has the key to room 7. So we'll unlock room 7 and retrieve key 4. Now we'll unlock room 4 and we find that there are no more keys. As we cannot continue any further, we'll stop. We see that we have unlocked 10 rooms and we have 10 rooms in total. So all the rooms are unlocked. In this approach, at each step, we are opening all the rooms we can and collecting all the keys inside them. In the next step, we are using all those keys to unlock all the rooms we can and we are collecting their keys. So at each step, we are visiting multiple rooms that we can. You can consider these rooms to be neighboring rooms and hence this traversal will become breadth first search. Now let's look at the depth first search approach. We are given that our room 0 is unlocked. We'll use the first key inside it. So now we'll unlock room 3 and we'll use the first key inside it. Using that we'll unlock room 8. We find that there are no keys inside, so we'll stop. We came here through room 3, so we'll go back there and use the next available key. Now we'll unlock room 5. We'll use its first available key. We see that room 3 is already unlocked, so there is no point going forward. So we'll try the next available key. We'll unlock room 9 and use key 2. We'll unlock room 2 and use key 7. We'll unlock room 7 and use key 4. After unlocking room 4, we see that there are no keys. So we'll return back to room 7 and we find that there are no more available keys. We came from room 2, so we'll go back there. At room 2 also, we don't have any more available keys. We came from room 9 and we'll use the next available key. We'll open room 1. As there are no keys, we cannot go any further. So we'll start going back in our path. So we'll go back to room 9 and then room 5 and then to room 3 and then to room 0. We'll use the next available key in room 0, which is the key to room 6. We'll unlock room 6 and after that we have no more keys left. Even in this case, there are 10 rooms and we have unlocked all of them, so our answer will be true. In this approach, we are trying to unlock the rooms as deep as possible with a particular key. Hence, this is a depth first search traversal. The time complexity of this would be O of n because we only have to go through all the rooms once. And the space complexity would be O of n heap memory in the case of BFS because we have to use a queue to maintain all the neighboring rooms. And the space complexity would be O of n stack memory in the case of DFS because of a recursive call stack. Let's implement both these solutions. Let's implement the DFS approach. We'll have to keep a hash set to track all the unlocked rooms. Initially, our room 0 is unlocked, so we'll add it to the hash set. Now we'll define our DFS recursive function, which will take a room number as an input. And for that room, we'll go through all the available keys. And if that key is for a room which is already unlocked, then we'll skip it. This is to avoid ending up in a cycle. Now we'll mark that room as unlocked, and we'll go to that room and repeat this process. We are given that our room 0 is unlocked, so we'll call DFS on it. And at the end, we'll check if the number of rooms that we have unlocked is equal to the total number of rooms. Then we can return true. We are done with the DFS implementation. Let's look at the BFS implementation. We'll define a queue for a BFS traversal, and since we are starting from room 0, we'll add it to it. Similar to our DFS implementation, we'll keep a hash set to track all the rooms which are unlocked. Room 0 is already unlocked, so we'll add it to the hash set. We'll do our BFS traversal till our queue is not empty. We'll pop the queue from the left to get our current room. Similar to our DFS, we'll check all the keys for that room. If that key is to a room which is already unlocked, then we'll skip it. We'll now mark this room as unlocked. And finally, we'll add this room to our queue so that it is available in the next step in our BFS. Now we are done with our BFS traversal. Finally, we'll check if the number of rooms unlocked is equal to the total number of rooms. We'll return true. We'll reuse this condition as it is from our DFS function. Let's submit our BFS solution. This solution is accepted. If you have any doubts or concerns regarding this solution, please mention in the comments. If this video was helpful, please leave a like and subscribe to the channel for more such content. Thanks for watching.